Hello everyone. In this video we're going to be solving an exponential equation with logarithms. So you get the best of both worlds. We have x to the power log x equals 10 to the power 10 to the power 10. So it's kind of like a tower of tens. And log x in this case is meant to be base 10, not the natural log like some people think. I don't know why. Some books unfortunately use log for natural logarithm, which should be ln. Now, to solve this problem, we can actually consider two different approaches. And one of them is since we are dealing with log x, we can kind of assume x to be a power of 10, right? Because when you say log x is equal to something, let's say log x is equal to a, by the way, this would be considered substitution, then because the base is 10, you can write this as x equals 10 to the power a. So in a way, we're assuming that x is a power of 10. Doesn't have to be an integer power, doesn't have to be a rational power, doesn't have to be irrational power. Some power of 10, okay? And now we can kind of plug it into our equation and try to solve for that one. So that's one way to approach it. We could also do this, just set x equal to some power of a, like I was saying. So this is what we're going to do. Now, if you replace x with 10 to the power a, what happens is you get 10 to the power a to the power log x, which is equal to a. And then that becomes equal to 10 to the power 10 to the power 10. Nice. Do you like that? Now, we're going to go ahead and use the superpower property. And from here, we're going to get 10 to the power a squared equals 10 to the power 10 to the power 10. By the way, if you want to know what kind of number you're dealing with when you see something like a tower, right, a power tower like this one, 10 to the power 10 to the power 10, what kind of number are we dealing with, right? Well, you're basically dealing with a number this long. Basically, this number that we're dealing with here, 10 to the power 10 to the power 10, is a number with this many decimal digits. And what is that number? It is 10 billion 1 digits. Think about it. Where does the 1 come from? You have 1 followed by 10 billion zeros. That's basically what it means. That number is huge. I don't think you will have enough time to write it, or maybe if you do, it's going to take a long time. So, having said that, let's go ahead and pick it up from here. We have 10 to the power a squared equals 10 to the power 10 to the power 10. And now this will be fairly easy to solve, don't you think? Because now we have the same base, and if you just set the exponents equal to each other, like this, a squared should equal 10 to the power 10. We should be able to find a solution, right? Well, which number squared equals 10 to the power 10? 10 to the power square root of 10? 10 to the power 5? Which one? Okay, here's what you can do. You can take the square root of both sides. By the way, can a be negative? That's a good question, right? Let's just consider both cases. So if you take the square root, a can be the square root of 10 to the 10, or it can be the opposite. But of course, we kind of have to check this with the original problem, okay? Now, how do you square root 10 to the power 10? Well, you just divide it by 2. It becomes 10 to the power 5. In other words, a is 1 with 5 zeros. And what is that number? That is 100,000, right? This is one of the values of a. Now, would this work? Let's go back and actually check with the original problem. What is a? A is equal to log x. And then the question is, can log x be negative? And the answer is yes. Why not? So one thing we didn't talk about, the domain. Can x be negative? No, because we're working with the real numbers. And by the way, I have another channel that focuses on non-real and complex numbers, and that's called aplusbi. Check it out and let me know what you think. But in this case, x needs to be positive because of the definition of the log function. So, but log x doesn't have to be positive, right? Because in order for log x to be positive, x had to be greater than 1. There's no requirement that says that. So this is perfectly fine. This means a is equal to negative 10 to the 5th power, or a is equal to 100,000. And remember, a is equal to log x. You could probably keep it as is. Log x is equal to a, which is 10 to the 5th power. So from here, because the base is 10, x becomes 10 to the power 10 to the power 5. What happens here? And by the way, I meant to put a minus sign here. If you use this, log x is equal to negative 10 to the 5th power. And from here, x becomes 10 to the power negative 10 to the 5th power. Guess what that means? It just means the reciprocal of this number. 1 over 10 to the power 10 to the power 5. Okay? So those would be valid solutions as far as I know. Let's go ahead and take a look at another approach. And I'm going to call this one the second method. The first one is called the first method. Even though we didn't write that down, let's go ahead and write it down. Okay, great. Let's go ahead and take a look at the original problem one more time. We have x to the power log x equals 10 to the power 10 to the power 10. By the way, there's a way to verify this solution. If you go ahead and replace x with 10 to the power 10 to the 5th, it should work. Okay? You can basically just go ahead and check it out. All right, great. So now the second method, what is it going to use, right? Well, for the second method, we can do this because we have a lot of powers and the variable is an exponent. So I think we should log both sides. That makes sense, doesn't it? So we can go ahead and move this to the right to make some room and then log both sides. So we can put a log here and a log here. And the properties of logarithms tell us that we can actually move the exponent, right? And I gotta put it back. Oops. And I don't think I need that anymore. So this is log x. And now what this does is we're gonna move this to the front. It's gonna be log x times log x. And then we're gonna move this to the front. It's gonna be 10 to the power 10 times log 10. But as you know, log 10 is equal to 1, so you can totally forget about it. And guess what this gives us? Log x to the second power equals 10 to the 10th. And then we kind of split up the same way before. Log x becomes the square root of 10 to the 10th power, which is 10 to the 5th power. And then log x can be the opposite of that number. And from here, obviously, you know the drill, right? X equals 10 to the 10 to the 5th, and x equals 10 to the power negative 10 to the 5th. Let's go ahead and take one of these and actually check it out with the original problem to make sure that we're not making any mistakes. But it's probably very unlikely that we would make the same mistake twice, right? But let's still check it out. Is it true for this x value, and of course the other one hopefully is going to satisfy, that we get the following result? So 10 to the power 10 to the power 5 to the power log 10 to the power 10 to the power 5. Does that really give us 10 to the power 10 to the power 10? Let's check it out. Well, first of all, there's nothing I can do inside, so I'm going to keep it that way. But here, I can actually move this. That gives me 10 to the power 5 times log 10, which is 1, so I can just write it as 10 to the 5th power. Now, we do apply the superpower property again, and we go ahead and multiply these two exponents. And when you multiply them, of course, another rule applies. You're supposed to add the powers or the exponents. That gives you 10 to the power 10 to the power 5 plus 5, which is 10. Therefore, the original equation is satisfied. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time in another video. Until then, be safe, take care. Don't forget to check out SyberMath, the Shorts channel, and aplusbi, and bye-bye.